Let's analyze some different kinds of velocity time graphs. As we already studied that in velocity time graphs, the slope of velocity time graph gives us instantaneous acceleration, and the area between this curve and time axis gives us displacement. So here first we analyze three different kinds of VT graphs. The first one is the graph where velocity time graph is a horizontal straight line. So you can simply state the slope of the straight line is 0. So this is the graph which corresponds to zero acceleration, or this we can consider the graph of uniform motion. Here particle moves with a constant velocity, that is uniform motion. We talk about the second curve where velocity time graph is a straight line, and we can see this line makes an acute angle with the time axis. So here we can consider as in the straight line at every point the angle with the time axis is constant. Here acceleration is a constant, and we can also call it positive because it makes an acute angle. That means the speed is increasing. So this is the case of increasing speed, where speed increases with time. In the third case, again it is a straight line. So here find the angle which the line makes with the time axis, it is obtuse. So here we can again state that acceleration is constant because in a straight line always the slope remains constant, the acceleration is negative, but here speed you can say it is decreasing. So this decreasing speed graph. So we can also state as the velocity is increasing, here velocity is positive, so acceleration is positive, as well as velocity is positive, that means the speed is increasing. Similarly in this case you can see acceleration is negative, but here velocity is positive. As acceleration is in the direction opposite to velocity, that means it must be decreasing. Here acceleration is in the direction of velocity, so that means the speed is increasing. Let's see some more velocity time graphs and their analysis. Say in graph number 4, if we can see that velocity time graph is a curve. That means here the angle which the tangent makes with the time axis is continuously changing. If we just think about the angle made by the tangent at two different times, say t1 and t2, you can see at time t2 the angle is increased. This theta is more than this theta. That means here we can say this is the situation of a variable acceleration, and as acceleration is given by the slope, here angle theta is increasing. So here we can simply state it is the case of increasing acceleration. And as theta is acute, here acceleration is positive, and as velocity is obviously positive in this case, so we can simply state both are in same direction, v vector and a vector. So here this is the case of increasing speed. Speed will continuously increase in this situation. If we talk about graph number 5, here we can again state as VT curve is a curve, this is the situation of variable acceleration. If we just talk about the slopes at time t1 and t2, you can see at time t1 and at time t2, we can see that at time t2 the straight line which is representing the tangent is steeper than the tangent at time t1. So we can state the acceleration is increasing, but here the angle made by the tangent with the time axis is obtuse, so here acceleration is negative. If acceleration is negative and as velocity in this situation is positive, we can state that the speed is decreasing. This is the situation of again increasing acceleration but decreasing speed. Again we must state as steepness of tangent is increasing, which is representing the acceleration, so it is increasing. But acceleration is negative because it makes an obtuse angle with the positive direction of time axis, So it is opposite to velocity. That's why we can say speed is decreasing. Similarly, in the third case or graph number 6, we can say again it is a curve. There is also the case of variable acceleration, and in this situation if at two different times t1 and t2 if we draw the slope, so at these two times we can see that the angle made by the tangent with the positive direction of time axis is acute. This is the case where we can say acceleration is positive. Here velocity is also positive. So in this situation we can state speed is increasing because both are in same direction, but we can see that the slope steepness is decreasing or the angle made by the tangent with the time axis is decreasing. This is the case which belongs to the category of decreasing acceleration. But as acceleration is in the same direction of velocity, here speed will increase. So this is the case of increasing speed. I hope all of you have understood very well how to analyze such graphs. There can be more graphs we can draw on velocity time, but I leave it to you. You just draw, experiment on various ways, what all type of graphs can be drawn, and you just analyze in the same way. These are the basic analysis which we generally do for velocity time graphs. In this question, we are given with a tower from the top of which a ball is thrown upward with the initial speed u. It goes up and then finally hits the ground. Similar situation we have analyzed in a previous section when we were drawing displacement time graphs. Here in this question we are said that a boy on the top of a tower of height h throws a ball up with initial speed u. And now taking upward direction positive, we are required to draw the velocity time curve. In the previous section, we have studied similar example where we have drawn a displacement time curve. Here we are required to draw the velocity time curve for ball's motion till it hits the ground. So say again we consider at t equals to 0 the ball was thrown. At time t1 it reaches maximum height where final velocity becomes 0. At time 2t1 it will be back to the same level from which it was thrown, and say at time t2 it will finally hit the ground in opposite direction with a velocity say vf. So in this situation again from the starting point if we take it as origin, upward direction we consider as plus x-axis, downward we take as minus x-axis, and again the acceleration as throughout motion acceleration is in downward direction, this we take as minus g. Now in this situation if we draw the velocity time curve for ball's motion, initially in the beginning you can say the particle was started with the positive velocity in upward direction. So initially at t equal to 0 the velocity was u, and at time t1 the velocity will become 0. So at time t1 the graph will come down like this, and it must be a straight line because the particle is moving at a uniform acceleration which is negative. So it is a straight line with a negative slope, and throughout motion we can see acceleration is constant, it is not changing. So the same straight line will be further extended and say up to a time 2t1 when particle will reach the same level from where it was thrown. It will be having the same velocity u in downward direction at this point, this is minus u, and it will further carry on till time t2 when particle will hit the ground where its velocity will be minus vf. This is the time t2 where particle will hit the ground. So same straight line will be carried on as velocity time graph, as throughout motion the acceleration is minus g. So as neither direction nor magnitude of acceleration is changing, so the straight line will be carried on from a starting to the end point of motion, that is the time when this ball will hit the ground. In this example, it is said that a ball is dropped at t equal to 0 from a height h as shown. This ball is dropped at t equals to 0. As it is dropped, we can take its initial velocity to be 0. It collides elastically with the floor. Elastically collision or elastic collision means the ball rebounds with the same speed. Say it strikes the floor with the speed v, then it rebounds with the same speed v. You just always keep in mind one thing. When we talk about elastic collision, here no energy is lost. Always keep this thing in mind. The kinetic energy with which a ball strikes the floor, with the same kinetic energy it rebounds. That means the speed remains same, the direction of velocity only changes. And it rebounds to the same height. Obviously, if the velocity is same, it will be able to reach the same height where final velocity will again become 0. We are required to draw the velocity versus time graph for ball's motion taking downward direction positive. In this situation, we are given that if we consider origin at the starting point, here we take downward direction as positive x and upward direction as negative x. Here, if we draw the velocity time graph for this motion, we can see at t equal to 0 particle started from rest, so graph must start from origin. And as throughout motion its acceleration is downward, so we take acceleration as plus g, because downward direction we are taking positive. So it will move with a uniform acceleration, so velocity time curve will be a straight line of positive slope. It will go on say up to a time t1, say at t equal to 0 it was released, then at time t1 we consider collision takes place. If ball will not lose any time in the contact, it will be rebounded, so it will take again the same time t1 in coming back. So the time at which it will reach the topmost point is 2t1. But at the instant of collision, the direction of velocity is reverse. So at this point, the velocity is say v. Say we take this velocity as v1. So it will also rebound with the velocity v1, but its direction is changed. So at this time t1, just after t1, the velocity is changed to minus v1, and then the same straight line will carry on till time 2t1. The initial time was 0, and at time t1 it strikes the floor, its velocity is reversed, and the straight line will remain same, because still during upward motion acceleration is positive, velocity is negative, and it is uniform. The same straight line will carry on in the graph with the positive slope, and its tan theta we can simply write it is equals to g, that is the acceleration. So this is the complete velocity time graph of the motion. For the same motion, it is not asked in the question, but if we wish we can easily draw the displacement time graph also. Let us draw it. However, it is not asked in the question, but we can draw it. If we draw the displacement time graph, we can take up downward direction positive. So during downward motion we can see velocity is positive as well as acceleration is positive. So we'll draw the graph like this, which corresponds to positive velocity and positive acceleration. And at time t1 it will strike the ground, which is at a position h. And then it will rebound when velocity becomes negative and acceleration is positive. So curve will be drawn like this, and at time 2t1 again the ball will reach the origin. So this is the graph for negative velocity and positive acceleration. So in such a way you just need to combine various graphs which we have already studied in earlier sections.